So in this video, I wanted to go over the solutions to the percent yield questions worksheet. I do want to make a note that in some, when I look at some of the questions, I had to modify some of them in the solution here because some of the answers, questions, the way they were asked would not have made sense. I will pause in at those moments. All right. So the first one we did in class, again, balance your equation. All right, and you want to first, whenever you're doing these percent yield problems, the first thing that you want to do is figure out your theoretical yields. All right, and theoretical yields are the maximum amount of your product that you could make. All right, so if we in questions where you have more than one reagent or reactant, you want to figure out which one runs out first. All right, so we're going to calculate the number of moles of each and divide each by the coefficient in the balanced reaction, and that gives us a number. And what we do with that number is we say that the smaller of those numbers is the one that tells us the limiting reagent. All right, so this little calculation of calculating the moles, dividing by the coefficients gives us these numbers. Since this number is smaller, that proves that antimony is the limiting reagent. All right, we can then, we're now going to calculate the amount of our product here that we could make based on the amount of antimony that we have. All right, so here's an important point. Always start off the next crossbar, with the top number, not the thing that you divided by. All right, so do it like this. We're going to use that number right here, and then we can say, based on these coefficients, that for every 2 of these, we should be able to make 2 of these. All right, so that's why we can say for every 2 moles of this, we should be able to make 2 moles of that, and then we figure out how many grams that would correspond to. All right, and we calculate 3.55 grams. All right, so remember our percent yield is experimental yield divided by theoretical yield. So remember, the theoretical yield is the amount that you could make. So that's going to go on the bottom. All right, and then we're going to put our experimental yield on top. And the experimental yield is what is given to us in the problem. All right, when it says this is how much is made or this is how much is produced, that would be a clue that that is your experimental yield. And we end up getting 54%. Notice I give it in 2 significant figures because when you divide these right here, this has got 2 sig figs, and that would dictate that this should have 2 sig figs. All right, in the next question, I have to do a little modification. We're going to say 6.7 liters of oxygen gas is produced. All right, so if you want to pause the video and try this problem with this new information, go ahead and do that. And if you've done it, great. If you're just following along with this, let's see how this would work. All right. So one thing that's a little bit different about this problem is that there's only one reactant on the in this. All right. And if there's only one reactant in an equation, it's automatically the limiting reagent. All right. So remember, normally the way we figure out if the maximum amount of products is to figure out which thing runs out first. Well, if there's only one thing, it's going to be there's only one thing that could run out first. All right. So, what's different about this problem is it asks us to figure out the percent yields of 2 different products. All right. So we should be able to calculate a maximum amount of this that we could make, and we could calculate a maximum amount of this that we could make. All right. So we're going to do that the same way we've done before, where we first of all figure out the number of moles of our starting material. All right, and then we're going to set up 2 crossbars. One of them is going to be designed to figure out the theoretical yield of sodium fluoride, and the other is going to be designed to figure out the theoretical yield of oxygen. All right, because that's what the question asked us to figure out for both of these. All right, so in doing this, we can set up these 2 crossbars. All right, notice that in the second step, part of the crossbar, this is just the mole ratio that comes from That comes from the balanced equation. All right. In the first problem, notice I use the moles to grams ratio. And the reason I do that is that the question gives us the amount of sodium fluoride in grams. All right. So to do the percent yield, you need to compare the number of the actual number of grams to the theoretical number of grams. All right. So we can calculate that the percent yield is 56%. All right. In the oxygen one, all right, notice that it gives us the amount of oxygen in liters. All right. So if we want to figure out the theoretical amount of liters of oxygen, well, when we get to this next point right here, we're going to use this relationship that allows us to get from moles of oxygen to liters of oxygen. All right, so that's why there's a slight difference between the last step here. You want to compare apples to apples. You want to compare, oops, I actually need to correct something right here. So this would be 6.7 liters to 14.3 liters. All right, and so when you do that, you would end up getting a 47% yield of oxygen. All right. In the next problem, all right, again, balance your equation. All right, we've got two reactants. We are going to figure out the number of moles of each of those. After we figure out the number of moles, we divide each by their coefficients. There's a 1 there. There's a 2 there. We then take that number, figure out which one is smaller. This is smaller. That proves that this right here is our limiting reagent. All right, notice, even though there's more moles of this, because we need twice as many moles to match this, it actually ends up being the thing that runs out first. All right, so therefore we start the next part of the problem. And by the way, I had to change this to 15 right here. So if you're doing this problem, just change that to 15 because it wouldn't make sense to have the 23.5. So you are going to start the next one with the number of moles here. All right, you put in the mole ratio from the balanced reaction up here. And let me zoom out here. All right, and once you do that, you get 18 grams of zinc hydroxide. Notice there's only 2 sig figs in this number right here because there's only 2 sig figs right here. All right, that reminds me, when you're doing this, go ahead and put a decimal point after the 20, and that allows there to be 2 sig figs in this number right here as well. All right, so when you do this, this is your theoretical yield. We can put that on the bottom. We'll take our actual yield right here, put that on top, and we get this percent yield. All right, so hopefully you can see now why I changed this number right here in the problem. If this had been 23.5 grams, that actually would have been more than is actually possible. All right, it would be like saying that I made 10 bikes from 3 wheels. All right, and that's not mathematically possible. All right, so the last one right here. We are going to, the only change here is, let's change this from 1.2 milliliters to 1.2 grams. There is a way you can do this from milliliters, but we're going to keep it a little simpler here. All right, so let's calculate our limiting reagent the same way that we have. Notice that in this problem, it's a 1-to-1 mole ratio between these two things. So that makes it really easy because when you divide any amount by 1, it becomes itself. So in this case, you can look at these two numbers directly and just say which one is smaller. All right, but if you divide each one by 1, you'll see that it's the same number. So what that proves is this is the limiting reagent. So we're actually not going to need this part down here anymore. And we put this into a crossbar, and we calculate the number of theoretical grams of HNO3, because that's what it's asking us to get the percent yield of. We get that, and we plug that into the percent yield problem, and we get a 22% yield.